And we're live and we're doing quartic equations today. Quartic equations are of the form ax to the power of 4 plus bx cubed plus cx squared plus dx plus a equals to 0. And suppose that this quartic equation has the roots alpha, beta, gamma and delta. Alright, let's express it as the product of its factors x minus alpha into x minus beta into x minus gamma into x minus delta is equal to 0. And let's label this equation as equation star. And now let's expand the brackets in equation star. And then let's compare the coefficients of the two equations. Actually, let's divide that first equation by a and then compare the coefficients to find out that sigma alpha is actually equal to minus b by a. And sigma alpha beta is c by a. I'll talk about that later, but hold on. Sigma alpha beta is c by a, and sigma alpha beta gamma is minus d by a. And the product of the roots is actually equal to e by a. Alright, let's take down a note here, a trick to remember this stuff. Note that sigma alpha beta is actually taking the product of the roots in pairs. And that is alpha beta plus beta gamma plus gamma delta plus alpha gamma plus beta delta plus alpha delta is equal to 0. That's sigma alpha beta. So the trick here is to write down the four roots and take them two at a time as I show you now. That's the easiest way to remember it. And this trick is for sigma alpha beta. And now let's take down another note, and that is for sigma alpha beta gamma. This is basically alpha beta gamma plus beta gamma delta plus alpha beta delta. Oops, it should be alpha beta delta. Hold on a second. Plus alpha gamma delta. So the trick here is you write down the four roots again and take them three at a time as I show you now. That's the easiest way to remember it. And then beta gamma delta, then alpha beta delta, and then alpha gamma delta. Alright, so you study these four, we will be pivotal in answering questions. And now let's look at another note, and that is sigma 1 of alpha. Sigma 1 over alpha is equal to 1 over alpha plus 1 over beta plus 1 over gamma plus 1 over delta. Take two fractions at a time and take the LCM and simplify alpha beta, beta plus alpha, plus the denominator you have gamma delta and the numerator gamma plus delta. Simplify that. You will find out that sigma 1 of alpha is actually equal to sigma alpha beta gamma over alpha beta gamma delta. By the way, sigma alpha beta gamma is taking the sum of the products of the roots by taking three at a time. So sigma 1 of alpha is actually equal to sigma alpha beta gamma over alpha beta gamma delta. So now let's find an equation when the roots are provided. So the first method is a generic form of a quadratic equation. And the form is x squared minus sigma alpha x plus alpha beta is equal to 0. And for cubic equations, the generic form is x cubed minus sigma alpha x squared plus sigma alpha beta x minus alpha beta gamma is equal to 0. And for quartic equations, actually then the general form is as follows. So that's x to the power of 4 minus sigma alpha x cubed plus sigma alpha beta x squared minus sigma alpha beta gamma x plus alpha beta gamma delta is equal to 0. And that is that. So now let's take a look at an example where you will apply the generic form of these three equations. Types of equation types, polynomial equations. Alright, so this is first example. Let me write that down. 3x squared plus 9x minus 11 is equal to 0 has roots alpha and beta. And this is a quadratic polynomial equation. So let's find the quadratic polynomial equation having roots alpha plus beta and alpha beta. So the first step here is to write down sigma alpha for the first equation, that is minus 3. And alpha beta is actually minus 11 over 3. So using the generic form of the quadratic equation I said before, let's construct the new equation. Remember that the new equation has roots alpha plus beta and alpha beta. So now let's construct the equation x squared minus the sum of the roots. So that's alpha plus beta plus alpha beta. X plus the product of the roots. That's alpha plus beta into alpha beta. So now just note that I'm emphasizing that for the new equation the roots are alpha plus beta and alpha beta. This is extremely important to understand, otherwise you will go wrong. So now let's substitute the values for alpha plus beta and alpha beta. X squared minus alpha plus beta is minus 3 over there, as you can see, and alpha beta is minus 11 over 3. And same goes for the other two as well. And now of course let's simplify. So that will yield you 3x squared plus 20x plus 33 is equal to 0. And now let's move on to equations with related roots. It's best explained with an example. So if there is equation 2x squared minus 5x plus 3 is equal to 0, is actually equal to 0, has roots alpha and beta. Find an equation having roots 3 alpha and 3 beta. So thrice the original roots of that equation. So 3 alpha is actually equal to 3 alpha. So let's denote the new root by y and the old root alpha by x. So that implies that x is actually equal to y by 3. So now let's substitute for x in the original equation to x squared minus 5x plus 3 equal to 0. And simplify. So that will give you 2y squared minus 15y plus 27 is equal to 0. And that's all for this video. And I'll see you in the next one where I'll discuss more questions on roots of polynomials.